This is Algebra 2 with Trig. This is moving on with the Semester 1 exam review. We're getting real close to Unit 2, but to finish up Unit 1, we identify the vertex of each of these. This is vertex form. So we, of course, are going to say -5, 0, because this is the h and the k. The k is 0. The h would have to be a negative for your equation to come out to be x plus 5. This here is intercept form. So this is your p and the q. So x is going to be p plus q divided by 2. So that's going to be -4 divided by 2, which is -2. That's your x value of your vertex, which is your line of symmetry. Then we're going to plug that back into the equation. And that's going to give us y equals -2 times 5 times -5. So this looks like it is -25 times a -2, which is positive 50. So we have -2 positive 50. This is standard form. So in standard form, to find the vertex, we have to do -b over 2a. So negative and -9 over 2 times a, which is 9 over 6, which is 3.5. So then we're going to plug that back in. So we get 3 times 3/2 squared minus 9 times 3/2 plus 1. This is going to be 3 times 9 over 4 minus 27 over 2 plus 1. Well, this is 27 over 4. This would be -54 over 4. We need common denominators, so we're going to times by 2 and times by 2. And then we would have 4 over 4. So our y value, this would be -27 plus 4 more, which would be -23. That seems reasonable to me. Now we're starting Unit 2. So to simplify, we're going to have -4 and we're squaring it. We're going to have x to the 4th and we're squaring it. We're going to have y to the 6th and we're squaring it. And we're going to have z to the 8th and we're squaring it. Well, that's going to give us positive 16, x to the 8th, because it's 2 times 4 is 8, y to the 12th, because 2 times 6, and z to the 16th, because it's 8 times 2. So we're going to get a to the 12th divided by b to the 9th. We're going to factor completely. So this is the sum of two squares. So the cube root and the cube root, and then we square it. We multiply the two together and change the sign, and we square it. This is the difference of two squares. So go ahead, pause the video, and see if you can use that same method. We can take this cube root, we can take the cube root. Now we square the first term, we multiply the two together and change the sign, and square the next term. We're going to use synthetic substitution. So we're going to take our 2 and plug it into the coefficients. or use the coefficients. I guess it's not plugging in. That's a positive 17. So f of 2 equals 38. Direct substitution, that's when we plug the x right into the x value. So that's 9. It's not 12 squared. This is 9. 3 squared times 4. So 9 times 4 is 36. So now we get 27 plus 5, which is 32. So f of 3 equals 32. We're going to find the difference. Now the big deal with difference is that you have to distribute your negative all the way through. So we have 10h cubed plus 9h squared plus 7h minus 5, and then we have minus 3h cubed minus 4h and a plus 3. You have to distribute the negative all the way through here. So we'll get 7h cubed. We don't have any other squares, so this is plus 9h squared plus 3h minus 2. Because the negative 5 and the positive 3 gives you a negative 2. The sum is just collecting like terms. So we have 1 and 5, which is 6x cubed. Negative and a positive is a negative 2x squared. A positive 5 and a 4 is a positive x. And negative 3 and positive 7 is a positive 4. To find the product, we have to multiply through. So we're going to get 2x cubed minus 4x squared minus 5x. Then we have to come through with the 4 to get 8x squared minus 16x minus 20. So our terms are going to be 2x cubed. Now we've used that one. So a square and a square is going to give us 4x squared. Both negative gives us negative 21x minus 20. That's what I see. So here we're going to produce something like that. We're going to first FOIL and then we'll have our binomial next. So we're going to say 2x squared plus 8x minus 1x is 7x minus 4. Now we have our x minus 3. Now we'll do the same thing we did before. So we get 2x cubed plus 7x squared minus 4x minus 6x squared minus 21x plus 12. And collect our like terms. So we have 2x cubed, a squared and a squared. It's going to give us just the x squared. Negative 4, negative 21 gives us negative 25, and a positive 12. So we look at number 11. And that looks to be the difference of two squares. So that's 2x minus 9 and 2x plus 9. Here it looks like there's a GCF, so we'll pull out what we can. And that's going to leave us 5x, with an x and an x, a 4 and a 1. That multiplies to be 5. Or, well, it's adding to be 5 and multiplying to be 4. Here we can pull out our GCF and we're left with k to the 4th minus 25, and that is the difference of two squares. So we're still going to have the 5k, and then we'll have k squared minus 5 and k squared plus 5. Here we seem to have another GCF, so that would leave us with 50m squared plus 10m plus 1. And I don't see that as factorable. Actually, this isn't 50, because if it was 50, 8 times 50 is 400. This is 25. That makes 200. Now we look at this, and we can see that we have our 8m squared, and this is the difference of two squares again. You can take the square root of this one. You can take the square root of that one, and together, when you take the square root, you get 5, and 1 in the middle is 2 times that amount. The difference of two squares, but notice how this is x to the 4th. So we're going to have 4x squared minus 25, 4x squared plus 25. And that breaks down into its own difference of two squares. But notice how this one will not, because there is no such thing as the sum of two squares. You cannot factor the sum of two squares. So 16, we're going to pull out the 2. And then we can look at the cubed root and the cubed root and square, multiply the two together and change the sign and square. Find the real solutions of this equation. It looks like we can pull the x out. And then we use the zero product property. So we're going to have x equals 0 and x equals plus or minus root 6. Now the square root of 6 is not reducible. Long division. This is number 18. So I've written out the problem. We have our divisor as x squared plus 2x minus 4. And then notice how here we have x to the 4th, the 3rd, the 2nd. There is no x in the original problem, so we have to have a place value holder. So now we're going to take x to the 4th divided by x squared, leaves us with 5x squared. So we write our 5x squared in the square column. Then we have to distribute through. So we get 5x to the 4th plus 10x squared, actually 10x cubed, because we have 2 and 1 makes 3. Then we get negative 20x squared. Then go through and change all the signs. I like to circle my new value. Notice how these cross out. They should always cross out. So we get negative 12x cubed plus 13x squared and 0 x's. Then we're going to take the negative 12x cubed and divide it by the x squared. That gives us negative 12x, and that's under the x column. So then we distribute it through to all three. So we get negative 12x cubed, because negative 12x times x squared gives us three different x's. Negative 12 times 2 is negative 24. X and x is x squared. Negative 12 and negative 4 is 48. X and nothing is just x. Change the signs. These should cross out. A negative and a positive will always cross out. We've got 37. And we've got negative 48. And bring down your negative 39. That's a negative, not a positive. And we take our 37x, x squared, and we divide it by x squared. What I hesitated there is that my exponents always have to be more on top, or at least equal. They wouldn't be smaller. So those cross out, and I'm left with 37. So I'm going to put a 37 here and distribute. Notice how those match. They have to match. So 37 and 37 is going to be 74, and 74 and 74 is 148. And then you come through and change the signs. These are going to cross out. They have to cross out. This becomes 112x. And this becomes a positive 109. Let me look at that again. This is 122. Here we get the 12, leaving with the 2, and that carry the 1 would be 7 and 5, which would be another 12. So 122. 110 and 12 more leaves you 122. The negatives will make that negative. So your final answer is 5x squared minus 12x plus 37. This is called a quotient, the answer of division, plus 122x and 109 over your divisor. Here we're going to list all the possible zeros. So what we're doing, we're looking for the factors of the constant divided by the factors of the leading coefficient. So that just gives us plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Those are your possible zeros. Those are the numbers that would best be available for guessing which is correct. We only have 4 possible answers. They're not all of these, but these are the reasonable choices. Here we have a rectangle. The area is x cubed plus 3x squared plus 3x plus 2. The width is x plus 2. What we don't know is the length. So we know that area equals length times width. So what's to figure out what the length is, we're going to divide the area by the width. Well, the width is x plus 2. So what we're going to do is set that to 0 and use negative 2. And then we're going to use our coefficients 1, 3, 3, and 2. Drop it down, multiply, 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 and notice we got 0. So that meant that x plus 2 goes into this evenly, which makes sense if they were actually two dimensions that gave us this area that would go in there evenly. So the missing length is going to be x squared plus x plus 1. The original degree was 3, so now we're going to be 1 less because we divided by x plus 2. We're going to factor completely. If we're going to factor completely here, we're going to look at the possible zeros. The possible zeros are plus or minus 1, plus or minus 2, 4, 8, and 16. Those are your possible zeros. Well, made that a little bit more complicated than we need to, huh? Let's first, before we consider all that craziness, let's just look at factor by grouping. We get x squared, leaves us with an x plus 1. Bring down your sign, factor out of 16. That leaves us with an x plus 1. Negative 16 times a positive 1 leaves us a negative 16. So this is this is x squared minus 16. Ooh, that's a difference of 2 squares. And then that can be broken down to x minus 4, x plus 4, and x plus 1. So if you think about the zeros, we had negative 1 as a 0, and we had plus or minus 4 as a 0. Now we'll look here for the possible zeros. It would just be plus or minus 1 and plus or minus 2. So what we can do to help us out, we could just randomly guess, just using those numbers, which would be completely fine because there's not too many choices. I want to be sure that you typed it in right. Let me be sure I did. So we have x to the 4th plus x cubed minus 3x squared minus 5x minus 2. So what we're going to do, we're going to look at some possible zeros. Which ones are the best to use? It looks like 2 is a pretty good choice. When I go to my table, I see that 2 gives us a 0. So I'm going to start right off using a 2. This is showing my work. I'm not using the calculator to do my work. I use the calculator to support my work. And look at that, I got a 0. That left me with x minus 2 is a factor. Since this is 4, this leading coefficient must be for a cube. So that makes this a squared, and this a x, and this a constant. Well, this is a cubic still, and it doesn't look like I can do factor by grouping. So I'm going to come in here and look at my graph again. Looks like that could be another spot. I think it might be hitting at negative 2 is a 0. No, sorry. I read it backwards. Negative 1 of x gives us a y that is a 0. So negative 1. So we're going to use the coefficients we got here. 1, 3, 3, 1. And we got a 0. So that means that x minus 2 is a factor. X plus 1 is a factor. And I'm left with x squared plus 2x plus 1. And actually that is factorable. X plus 1, x plus 1. So notice how we have 3 of the same factors. That's why our graph was making that funny curve right through here. That's a cubic curve right through there. Because we have 3 of the same type. So find the possibles, or find all the real zeros. So we set these to 0 now, so we get x equals 2, x equals negative 1 by doing the zero product property.